Hey guys, Miss C here. So these are the 5A.01 notes starting out our Unit 5 on logarithms. And so I'm going to start off these notes first talking about the warm-up that we did to start off class when we did these notes. And so the directions I gave you were just to solve for x. And I put 3 problems on the board. The first one was x plus 2 equals 7. The second one was 2x equals 22. And the last one here was x squared equals 81. And you might be looking at these and think, Missy, these are so simple. We've learned how to solve for x here. But just hold tight. What you would do here, in the first one you subtracted 2 from both sides. In the next one you divided 2 on both sides and got x equals 11. And in the last one you took the square root of both sides and got x equals positive and negative 9. And so what we talked about after this is how what you did to get from the blue to the green was you used the inverse operation in order to solve for x and to get x by itself. And so then I put another problem on the board and I said, okay, what if you had 2 to the x equals 32? How would you get x by itself there? And that leads us to our notes today about how the inverse of an exponential function is a logarithmic function. Okay, and so we're going to look at logarithmic and exponential functions and how you can switch forms and write in between them. And so the first thing I am going to write down here is the logarithmic form is x equals log base b of a. So how you say this is x equals, let's write that a little better, equals log base b of a. Okay? This value down here is your base, and this a here is our of, is what I'm going to refer it to, okay? And then in exponential form, how we see this is we have b to the x equals a. And so you see the same letters in both of these problems. You see the base in a different spot. So how you say this is b to the x equals a. And here you see that your base is in a new spot and your of is in a new spot. So when you are rewriting logs and exponentials, you're first going to want to find the base. And then the rest is quite simple from there. So let's do a few problems together. So I told you the first thing you need to do is find the base. And when it's written in log form, your base is down at the bottom. It's this 3 right here. And so how I would do this is I start with my base, and since it's in log form, I want to write it in exponential form. So I'm going to go to my base, and I'm going to go in a circle across the equal sign. So I'm going to say 3 raised to the y equals 5. And I just went from log form to exponential form. Okay, let's try number 2. First thing I'm doing is finding the base. So my base is a, and I'm going in a circle. I'm going across the equal sign. A to the negative 2 equals 7. That's it. Okay, let's do another one. Number 3, we find our base is 2, and we go in a circle. 2 to the 6th equals x, our of. Okay? Pause the video and try number 4 on your own. Alright, with number 4, the first thing you need to do is find your base of 10. And you go in a circle. 10 to the 4th equals x. Okay? Okay, number 5, these problems here going from exponential to log is the exact same process. First, you're finding your base, and in an exponential form, your base is what is attached to your exponent. So in this problem right here, my 10 is attached to my exponent, so 10 is my base. So when I'm writing in log form, my 10 goes down at the bottom. I'm still going in a circle. Log base 10 of 1,000 equals x. Okay, let's try number 6. First thing is find your base, which is 2. And so I am writing log base 2, going in a circle across the equal sign, of 8 equals x. Okay, pause and try 7 and 8 on your own. Number 7, I found my base of 7. And I would have log base 7 of y equals 2. In number 8, my base is 3. And I have log base 3 of 4 equals y in my circle. Okay? Okay, hopefully you feel good about the notes so far. If you're stuck or need to see this again, feel free to rewind. But now we're going to talk about solving equations, both in exponential and logarithmic form. So the first thing you want to do is isolate the base. Okay, so you're trying to get that number that is attached to your exponent completely by itself. From there, you're going to write both sides of the equation as exponential expressions with like bases. Okay? By like bases, I mean 2 to the x equals 2 to the x plus 7. Something like that, where your numbers here are identical. I don't care what's up in the exponent spot, but what is on the ground needs to match. Okay? From there, what you'll do is you will set the exponents equal to each other. And then solve for the unknown. So you actually learned this property in Algebra 1, where if you have like bases, like what we have right here, and they are raised to different values, then you can set those values equal to each other. So in number 1, you can see that our bases match each other. They both have a base of 5. And so that means I can set my exponents equal to each other. So I can say 2x minus 1 equals x plus 7. So from here, I'm going to solve for x, subtract x, add 1, and I would end up with x equals 8. Okay? Pause and try number 2 on your own. Okay, with number 2, you see that you have like bases again of 6 and 6. So I can just say, what color did I use here? Blue. Oh no. Sorry guys. So I can say that 5x is equal to 40, and now solve for x by dividing by 5, and I will also get x equals 8 for number 2. Okay, number 3 is a little different because our base is not isolated. So before we can do anything, the first thing we need to do is divide by 2 on both sides. So when I do that, I'm left with 3 to the 3x plus 2 equals 27. And from here, 3 and 27 are not the same. So this is when we're going to use our step number 2 from the top of our notes here. And we need to write the sides of this equation as like bases. So I'm going to rewrite 27 with a base of 3. So what I like to do is I'm going to break 27 down. The two factors that I think of are 3 and 9. And then I'm going to break down 9 again to 3 and 3. Well, here I see that I have 3 3's. So 27 can be rewritten as 3 to the 3rd, because I have 3 3's here. And so now I can write this as 3 to the 3x plus 2 equals 3 to the 3rd. Now that their bases match, I can set their exponents equal to each other and say 3x plus 2 equals 3. I'm going to move over here, and I would end up with 3x equals 1. X equals 1/3. The important thing is like bases here. use number 3 as a guide and try to do number 4 on your own. All right, first thing that you needed to do was to isolate your base, and so you want to add 7 to both sides, and you will end up with 2 to the 4x plus 1 equals 16. Again, 2 and 16 don't match, and so I'm going to rewrite 16. So I can think of 2 and 8, 2 and 4, 2 and 2. So here I see 4 2's, so I can rewrite 16 as 2 to the 4th. So now right here I'm going to end up with 2 to the 4x plus 1 equals 2 to the 4th. Now that my bases match, I can say that 4x plus 1 equals 4. Then I'm going to subtract 1 from both sides, end up with 4x equals 3, divide by 4 on both sides, and end up with x equals 3/4. Okay? Okay, logarithmic solving using with logarithmic equations is very similar, obviously, because they're inverse operations. They act very similarly. So the first thing that we want to do is isolate the log and convert the log to an exponential. And then from there, we are just solving just like we would in the problems that we just practiced with. So you're going to solve for the unknown, and you want to check your work. Now this is important because remember in our last unit we talked about how you could end up with extraneous solutions and you can get some problems that don't work. So that's what this box is actually for over here. For you to write yourself a reminder of what you cannot have. Remember when we had extraneous solutions with square roots? We had to make sure to not get a negative under the square root. So similarly with logs, what's important here is you cannot take the log of 0 or negative numbers. Okay? And so I intentionally said of here because it can equal a negative number, but it's just that your argument or what is in parentheses attached to the log cannot be 0 or a negative number. Okay? Okay, let's practice a little bit here. One thing I forgot to mention is this last awesome property that is very similar to the one we just talked about earlier, whereas if your bases match A and A right here, then your ofs are equal to each other. Your arguments are equal to each other here. And so just like in number 5, we see that our bases match each other. And so that means we can set our ofs equal to each other. So we have x squared minus 3x equals 10. And I see a quadratic or an exponent of 2, so I'm going to try to solve this by factoring and move everything to one side. And then I'm going to factor x minus 5, x plus 2 equals 0. And from here, I'm going to set both of my factors equal to 0. And I get x equals 5 and x minus 2 equals 0 and x equals 2. Negative 2, sorry. So you need to go back and check your x values. And so you're going to go back into your of. And so I'm going to check in green. And I'm going to plug in my 5 squared minus 3 times 5. This gives me 25 minus 15, which is 10. That's a positive number, not 0, so that works out. Now let's try the negative 2. I'm going to do negative 2 in light blue. So I'll have negative 2 squared minus 3 times negative 2. And this is going to end up giving me 4 plus 6, which is also 10, and that works out. And so both of these answers are correct, and neither of them are extraneous, and so we can box in both of those. Okay? Try number 6 on your own. Okay, so here we also have the same bases here, 4 and 4. So I can set their ofs equal to each other. 4x minus 1 equals 29. And I'm just solving for x. Unlike number 5, there's no quadratic happening here. So I can just go right into 4x equals 30, and then x equals 15 over 2, or you could have said 7.5. Okay? Okay, 7 and 8. So number 7, this time we only have one log, not two logs. So we need to isolate our log, just like the steps above. So the first thing I need to do is divide by this 2 outside, and I am left with log base 2 of 3x equals negative 3. So from here I need to change this to exponential form like we did on the front of the notes. So I find my base, and I have 2, and I'm going in my circle. 2 to the negative 3 equals 3x. Okay, so 2 to the negative 3, this isn't something we have really talked about yet, but negative exponents, I want you to think about what negative exponents do to a number. They do not make the number negative. If you think of what 2 to the third is, 2 to the third is 8. 2 to the negative third is 1/8. Negative exponents give you fractions. Or here, I'll say this. Flip your number. So if 2 to the third is 8, here we have 1/8 equals 3x. And then from here, I'm going to be dividing by 3, which is the same thing as multiplying by its fraction or reciprocal. And so I'm left with x equals 1 over 24. Okay? Number 8, again here, we have to isolate our log. And so the first thing we're doing is dividing by 2 on both sides. And I'm left with log base 3 of x minus 1 equals 1. And I'm going to change it to log form. And I have 3 is my base to the first equals x minus 1. That x minus 1 is entirely in the of, so we don't need to move anything or add anything. But now we do, so I need to simplify this and say 3 to the first is just 3. And now I can add 1 to both sides, and I can say that x equals 4. Okay? Alright guys, hope this was helpful for those that either missed class or needed the refresher from this opening lesson. So stay tuned for the lesson about expanding logs coming up next.